Hello everyone, so in this video we will learn about nature of roots of quadratic equation. So let's begin our session with very positive energy. So now nature of roots of quadratic equation. Before coming to the nature of roots, we must understand what is discriminant. What is discriminant? So discriminant is nothing but just a value that is equal to b square minus 4ac. Now you will ask what is a, b and c. So for a quadratic equation, for any quadratic equation, the coefficient of x square is known as a. Coefficient of x is known as b, and the constant term is known as c. Constant term is that which is free from any kind of variable. So coefficient of x here is a, coefficient of x is b, and constant term is known as c. Let's see an example. If we have an quadratic equation 5x square plus 6x plus 2 is equal to 0. So coefficient of x square, coefficient mean whatever is placed in front of x square is coefficient of x square. So here the coefficient of x square is 5, and we know that coefficient of x square is represented or denoted by a. So here value of a will be 5. Coefficient of x, whatever is placed in front of x, it is denoted by b. So here value of b is 6, and the constant term that is denoted by c, which is free from any kind of variable, is 2. So c, value of c will be 2. So now we have a as 5, b as 6, and c as 2. Now if we want to find the value of discriminant for this quadratic equation, it will be as d. D is used to represent discriminant is equal to b square minus 4ac. So value of b is 6 square minus 4 into a is 5 and c is 2. So it comes out to be 36 minus 4 into 5 is 20, and 20 into 2 is 40. So it comes out to be minus 4. Now, based on the value of discriminant, the nature of roots is decided. So let's see that. Now, based on the value of discriminant, we have three cases. So three cases are as: case number 1, when the value of discriminant is greater than 0, that means the value of discriminant is positive, because b square minus 4ac greater than 0 means it's a positive number. So it's come out to be positive discriminant. So in that case, we will have real and equal roots. That means the roots will be real number. We will have two roots, and both roots will be real number, but two different real number. So if one root is a, then another root will be b, but they can be plotted on the real axis. So this is the first case. Coming to the second case, if b square minus 4ac is equal to 0, in that case the value of discriminant will be 0. So in this case we will get real roots, but both roots will be equal. So if one root is a, then another root will also be a. And coming to the last and third case, if b square minus 4ac is less than 0, that means the value of discriminant is negative. In that case, we will have non-real roots or complex conjugate roots. So we will discuss these complex conjugate roots, and we have further two cases in that case. If b square minus 4 is perfect square or non-perfect square, we will also discuss that case. So now we will see some examples for each of these cases. Now let us consider an example. Example number 1. Let's say quadratic equation is x square plus 5x plus 6. Now first of all we will find the value of discriminant for this quadratic equation. d is equal to b square minus 4ac. Now in this case, the value of a is equal to 1 because the coefficient of x square is 1. The value of b is 5 because coefficient of x is 5 and the constant term c is 6. So now a is 1, b is 5 and c is 6. Now putting this value in this formula, d is equal to b square. That means 5 square minus 4 into a is 1 and c is 6. So it will become 25 minus 4 into 1 into 6, 24. That comes out to be 1. So the value of discriminant is 1. So we clearly know that this is case number 1. Case number 1 where d greater than 0. Case number 1 where d greater than 0, we will get real and unequal roots. Unequal roots. So let's verify this case for this quadratic equation. So x square plus 5x plus 6 is equal to 0. Let's solve this equation by splitting the middle term. So two number with product as 6 and sum as 5. We know that these two numbers are 2 and 3. So x square and 5x can be splitted as 2x plus 3x plus 6 is equal to 0. Now taking x as common, it will become x plus 2, and here taking 3 as common, 3, and it will also become x plus 2 is equal to 0. Now taking x plus 2 common, x plus 2, we will left with x plus 3 equal to 0. Now we have two cases, x plus 2 is equal to 0 and x plus 3 is equal to 0. Now x comes out to be minus 2 from this case and minus 3 from this case. Now we can clearly see that x is equal to minus 2 and x is equal to minus 3. We get two values of x. One is minus 2, one is minus 3. Both are real number and both are unequal. Minus 2 is not equal to minus 3. So yes, first case is completely verified. If d greater than 0, we get real and unequal roots. So let's see another example. Now example number 2, x square plus 4x plus 4. Now first of all, we will find the value of discriminant for this equation. Now d is equal to b square minus 4ac. Now in this case, value of a is 1 because the coefficient of x square is 1. The value of b is 4 because coefficient of x is 4 and the constant term c is equal to 4. Now putting all these value in this formula, so d will become b square, that is 4 square minus 4 into a is 1 into c is 4. So 4 square is 16 minus 4 into 1 into 4, 16, so 0. So in this case d comes out to be 0. Now we know that this is case number 2. Case 2, if d is equal to 0, in that case we will have real and equal roots. So let's verify this for this quadratic equation. Now putting x square plus 4x plus 4 equal to 0 in order to find the roots of this quadratic equation by splitting the middle term. So now two numbers with product as 4 and sum as 4, clearly 2 and 2. So clear x square plus splitting the 4x as 2x plus 2x plus 4 equal to 0, taking x as common, it will become x plus 2, and here taking 2 common, 2 into x plus 2 equal to 0. Now taking x plus 2 common, it will become x plus 2 into x plus 2 equal to 0. Now the two cases are x plus 2 equal to 0, x plus 2 equal to 0. Now from both cases, we get value of x as minus 2 and minus 2. So clearly both -2 and -2 are real numbers and both the roots are equal. So second case is verified, that if value of discriminant is equal to 0, in that case we will get real and equal roots. So let's see another example. So example number third is 5x square plus 6x plus 2. So first of all we will find the value of discriminant d is equal to b square minus 4ac for this equation. Here a is 5, b is 6 and c is clearly 2. So putting these value in this formula we will get d as b square, that means 6 square minus 4 into a. What is a? A is 5 into c. C is 2. So 6 square is 36 minus 4 into 5 into 2 comes out to be 40. So D is minus 4. So we know that this is case number 3. Case 3 where if d is less than 0 or d is negative, in that case we will get non-real roots, and the roots will in the form of complex conjugate format. So let's verify this case using this equation. Now equation is 5x square plus 6x plus 2. Now we will find the roots of this equation using Sridhar-Chare formula, that is x equal to minus b plus minus root b square minus 4ac upon 2a. So this is clearly value of discriminant. So now we know that for this equation the value of discriminant is minus 4. Now x will become, x is equal to minus b. Here b is 6. So minus of 6 plus minus under root b square minus 4 is minus 4 upon 2 into a. A is 5. So 2 into 5. Now this will become minus 6 plus minus under root minus 4 upon 10. Now clearly we can see that whenever there is negative number under the root, that number is not considered as real number, that number is considered as imaginary or non-real number. So we can not plot this number on the real axis, so the roots we get is non-real roots and they will be in the complex conjugate form. So that means if one root is minus 6 plus under root minus 4 upon 10, then the another root will be minus 6 minus under root minus 4 by 10. So this plus and minus format for complex number is known as complex conjugate format. So this is the case number 3, that we verified if d is less than 0 or d is negative. In that case we will get non-real roots or complex conjugate root format. So let's see another example. Now if d is greater than 0, the value of discriminant is greater than 0. We have two cases in that case, that value of discriminant is greater than 0 and it is a perfect square. It is a perfect square. And the second case is d is not a perfect square. So in case the d is greater than 0 and d is a perfect square, we will get real and rational roots. But if d is not a perfect square, in that case we will get real and irrational roots. So let's see some examples for both of these two cases. So the example is x square plus 10x plus 2. Now first of all we have to find the value of discriminant for this quadratic. So now d equal to b square minus 4ac b. Here a is 1, b is 10 and c is 2. So it will become b square. Now 10 square minus 4 into a is 1 and c is 2. So this will become 100 minus 8, that is 92. So this is case number 2 where d is greater than 0 but d is not a perfect square. So now we know that for case number 2, if d is greater than 0 and d is not a perfect square, in that case we will get real and irrational roots. Irrational roots. So let's verify. Now quadratic is x square plus 10x plus 2. Now we will find the roots of this equation using Sridharacharya formula. X is equal to minus b plus minus under root b square minus 4ac upon 2a. So here minus b, minus of 10 plus minus under root b square minus 4ac. Here is the value 92 upon 2 into a. So value of a is 1. So this comes out to be minus 10 plus minus under root 92 upon 2. Now we will try to prime factorize the 92. So 246 into 23. And we know that 23 cannot be further factorized because it is a prime number. So 23 into 23, 1. So now it can be written as minus 10 plus minus 2 under root 23 upon 2. Now taking 2 common in numerator, 2 minus 5 plus minus under root 23 upon 2. So the root we get as, so the final output is this, minus 5 plus minus under root 23. That is minus 5 plus under root 23 and minus 5 minus under root 23. Clearly both the roots are irrational number because both include under root 23 and the 23 is not a perfect square, so it cannot be further solved. So we get real but irrational roots. So let's see another example. So the example is x square plus 7x plus 10. Now d is equal to b square minus 4ac. So here a is 1, b is 7 and c is 10. So now d will become d is equal to b square. That means 7 square minus 4 into a 1 and c as 10. So now this will become 7 square is 49 minus 4 into 1 into 10 will become 40. So d comes out to be 9. And we know that 9 is perfect square. So this is case number 1. If d greater than 0 and d is a perfect square, d is a perfect square. So in that case we will get real and rational roots. So now let's verify for this equation. Now x square plus 7x plus 10. Now using formula x is equal to minus b plus minus under root d upon 2a. D here is discriminant and we know that the value of discriminant is b square minus 4ac. Now putting the values minus of b, that is minus of 7 plus minus under root d. The value of d is 9 upon 2 into a. A is 1. So we will get minus 7 plus minus under root 9 is 3 upon 2. So the two cases are first with plus and another with minus. Minus 7 plus 3 by 2 and minus 7 minus 3 by 2. So minus 3 minus 7 plus 3 is minus 4 by 2 and this comes out to be minus 2. And minus 7 minus 3 is minus 10. Minus 10 by 2 is minus 5. So clearly we can see that both minus 2 and minus 5 are rational number because both can be written as -2 by 1 and -5 by 1, and both are real roots. So I hope you enjoyed. Thank you so much.